Hello, hello. So it's 11 p.m. in Japan time. Let me know if you can hear my voice. Right. So I think I would like to start the live stream for today. So this is a live stream tutorial for Houdini, and the topic for today is to create a procedural jade vine. It's my plan. And what jade vine is a type of a plant or flower which looks like these, looks like a grape, grows like a grape from top to bottom, like a vine. So it grows up on the trees and create a vine like these and create a jade color flower like these. It's very interesting. So it seems to have some kind of a bean-like shape, and some jade colored flower will come up from these seed or bean. And that's what I'm planning to create as a 3D model, procedural 3D model today. Since I had created this procedural model for one of the workshop that I attended, so I thought it would be a good idea to just share how I create it. So it's not really exactly how it looks like a jade vein, but and I don't really know how it grows. So the growth animation part might be a fake, but even though the result that I created might be interesting for some of you, so why not just share it? Okay, so that's my plan for today. So this is the simulations or growth simulations that I'm going to create today. And there are a bunch of parametrical stuff you can control, like the length of the vine, how you can control the shape, and all sorts. You can also control the number of like flowers and so on. Everything is procedural, so you can just control it after you have created the system. Right, so that's my plan, and as always I'm going to create this flower system from scratch using Houdini. And most of the time I'll probably use Vex, and at some point I'm also going to use a simple rigging or KineFX stuff as well, just to create some simple animation or simple bending animation. Okay, so that's my plan. Let's start doing it. So like always, I'm going to start by creating a geometry node, and let's start creating the geometry. Alright, so before starting anything, I might also want to open up some sketch tool so that I can also explain in sketch and subpoint to tell you the steps how I'm going to deal with this shape. I am not sure how much time I'm going to spend in order to create this. It might take a while because there are a bunch of things that I need to do. So first things first, I'm going to create a basic vine stuff which grows from top to bottom. And while it's growing, should be creating some branches with a number of points you specified. And at each branch you'll be having a seed or bean. I heard that the jade vine is a type of a bean as a plant, so it could be a bean. And for each bean, I would also like to create some animations which opens up a flower by time. So something like this. So I'm assuming that the flowers it's stored inside this bean and being opened up over time like this. So I want to implement these animations to each of the beans, probably also related to how it grows, how the jade, how the vine grows from top to bottom. So gradually I might want to implement this animation to each beans, and maybe a bit randomly so that I could feel more organic. I mean, this could start first, these could start first, but maybe I can delay one of those beans to grow, but these ones starts to grow first. But later, maybe these ones start to grow as well later, to have some gaps between the frame gaps when it starts to grow, to have some organic effects, right? So that's my plan. So going back to the image, so if I look at these images, I can see that it grows from top to bottom like these, and like grape or like that. So I'm planning to, first of all, I'm planning to create these vine line, and might be interesting if I could also make it not too straight but also could be curvy, to have some interesting growth effect. So let's start by creating these vines, and let's also create those branch points as well. Right, so start. So probably I will start by creating a simple line. Goes from top to bottom, so I'm going to make the direction negative. Okay, so the starting point will be on the top, the end point will be on the bottom. Let's have enough control points in order to be able to create a curvy line, curvy curve. So I'm going to also create a null node where I can have a bunch of parameters that I want to control later, such as the length of the vine and so on. So let's first create one parameter which will be the length of the vine by drag and drop this length from line. Let's call this vine length. Okay. Okay, now so that I can control the length. Now I would like to make this line a bit wiggly, like a natural vine, maybe using something like noise functions. Okay, so I'm going to create a noise value using the point positions as well as some scaling to the points. Hello everybody, thanks for joining and thanks for saying. Okay, hope you I'm glad to hear my Vex work helped you. Music. Okay, so now I have a scale value multiplied to the positions to control the smoothness of the noise. And let's also apply this, subtract this directional vector with a 0.5 for each x and z, x, y, and z, since the range of the noise is from 0 to 1, so I'm remapping it to minus 0.5 to 0.5 for each coordinates, and also make this y value 0 so that I could only move the points in xz direction, and update the point position with the directional value created with the noise. Now I'm going to also multiply it with the amount of movement for the noise to control how much it moves. Okay, so that's the scale of the noise is but a bit too small, so I'm going to increase this to have a bit more natural shape. Okay, let me increase the range of the scale to 10. Also the movement maximum to 10 as well. Okay, so that might be too much, but maybe I could start with kind of a drastic example so that if I'm getting any errors with these drastic errors, and if I could fix that, it should be fine with less drastic examples. So my opinion is I think it's a good idea to start with a bit exaggerated parameter values to avoid failures in some situations, some unexceptional situations. Okay, so let's start with these setup. Okay, now next thing I'd like to do is to create some basic informations on each point on these curve. That is a tangent vector for each point, as well as, well, maybe just a tangent vector. Okay, so in order to do that, I am going to use a orientation along curve. Orientation along curve, and that will create a tangent vector as a normal vector. Just like that. Okay, which is useful in order to create a branch direction later. Hello. Konbanwa. Now, next, let me see. Let's also let's start creating some growth related attributes to this primitive, and that is a primitive attribute. I'd like to create a primitive attribute for this vine in order to control how fast it grows from start to end. And in order to control the speed, in order to create a start to end growth, I'm going to also use carve node, which I can control the second U to kind of trim the curve like these. And in order to control these values, I'm going to use, instead of constant value, I'm going to use attributes, which is a primitive attributes. And let's name that attribute growth, which I don't have it right now, so it gives you an error, but it's fine. So the growth is a single value, single flow value for each primitive, which can be used to control the growth of the curve. So let's try creating that here. So as a test, maybe I can create one parameter like this to see how it works. And now if I move this slider, yeah, the attribute's being used as a gross values in carve a node like this. But this is not that interesting enough, so in order to control how fast it grows, especially based on those time, like frames, I'm going to create some frame-based value beforehand in order to apply for growth attributes. Good evening from Japan. It's late night right now. Okay, so what I'm going to do is to first create a frame-based value by fit or remap the current frame, which goes from the first frame to whatever frame you want. Let's say you want to control how much of the frame you want to use for the final growth. So let's call this fend as an integer value. So I'm going to add a fend parameter to a fstart. Fstart means the first frame, in this case just 1. Then from fstart to fstart plus fend, I'm going to remap this value to 0 to 1, meaning normalizing the value, the frame value in between 0 and 1. And let's try to apply this f to gross value now, see what happens. And seems like I have some problem here. That is because I haven't set the fend yet. So let's set this fend, this integer fend value to 100. So this means from 1 to 101 frame, the value will be from 0 to 1. This f value will be from 0 to 1 from first frame to the 101 frame. Then I'm going to apply that f to the growth attributes, which will be used in carve node to grow the curve. Okay. And right now the growth is much of a linear growth, which isn't really which it looks a bit too artificial in terms of the speed. It just stops too sudden, so I probably want to stop the growth gradually slowing down, like gradually slowing down at the end. So in order to have that effect, I'm going to apply a chramp parameter to this f value to create a non-linear mapping to this f value. So if x axis stands for the current f, which is this f input, the second input for this ramp, and the y value corresponds as the remapped value. So what I would like to do is to First of all, make each of those markers B-spline, E-spline, so that it'll be more curved. And so at the end of the simulations, I want to make the speed slow. So if I will do something like this, it will slow down. The speed of the growth will slow down in the end. So it starts linearly first, but gradually it slows down to the end. So let's see what happens. So let me also toggle the real-time toggle and see what happens. Okay, let's also disable the normal visualization. So you can see that the growth slows down gradually in the end. So this is how you can control the speed of the growth. Okay, looks good. Maybe I could increase this frame end a little bit more, like 130. How's this? Okay, it's not bad. So let's go with these. Good afternoon, good evening. Okay, now I'm going to apply a group to this vine primitive. So let's create a group node. Call this root. Okay. Now it's time I create a branch to this curve, to this vine. So let's see how I could. And the plan is to create as much point as I want to on this curve, a growing vine. Then as soon as it appears, the vine appears, the new branch would also want to appear. But I also don't want to change the position of the branch over time, because that doesn't make any sense as a nature. So the position also must be fixed for over time. So in order to achieve that, what I'm going to do is to, there are several ways I could do. One of the way is to first going back to a oriental along curve and just scatter some points on top of it and use that point as a branch point, which then you could control the number of points, and if you want to have more even spaced points, you could increase the relax iterations value here, increase the relaxations like that. That's also fine. Or you could also do this everything in vex, but maybe shall we just use this scatter node for ease. Okay, now so in this case probably making all relaxed, making all those points distance same evenly is not really natural, so maybe I should avoid using relaxed iterations too much. Maybe having it a little bit is fine, but try to make it more natural. In order to make it more natural, should have some gaps like these, or even without it, looks like these. In this case, maybe some points are a bit too close, so might not be a good idea. Okay, so let's have some sorts of relaxations like this. Okay, it's fine. Now let's also have another parameter for a global controller, which is a number of points, or number of branches you want to use. So as well as a global seed, which could be used in other places for random seed value. Okay. Now, let's see what happens. So I can now control the number of points. Maybe the maximum is a bit too large for this one. So let's change this to just an integer. And then make the maximum 1000. Maybe 1000 is still too high as a number of flowers. Maybe 300 could be a maximum. Well, it's your choice. And changing the random seed will change how it scatters on top of the vine. Okay, now one thing I would like to have as an information for each point is the tangent vector from orient along curves. So let's see if it's have it. Okay, yeah, it does. Now another things that I would like these points to copy from the curve is in which index or in which positions it belongs to on this curve, meaning what's the u parameter on this curve for each point. U means a UV's U, which informs the positions on the curve. And currently, if I look at the scatter point, I believe it doesn't have that kind of information. So let's get that. So in order to get that, I could just use a point wrangle, or I could also use a node like resample node to orient along curve, which will resample the curve, but in this case I don't really need to resample, so I can just check off maximum segment lengths. But instead what I need to have is this curve U attribute, which is the positional informations, gives you an information from 0 to 1 from start point to the end point as a float value. So if I look at the point attribute, I'm now getting the 0 to 1 value on the control points of the curve. Now looking back to the scatter point, I can also see that those curve U value being copied to each point. It's good. The value is sorted randomly, so let's sort it out based on the curve U value so that it goes from start to the end. The order will go from start to the end. So use sort node for a point by attribute, use curve U. Okay, now let's check the order. So now the point has been reordered based on the curve U float attribute. Okay, and it still has a normal value which stands as a tangent vector value for each point based on the curve. Okay, looks good. Now let's start creating a branch line from each of those points using point wrangle for this. And let's also connect the root to the second input to control which point will show up, which branch should show up based on the root curve. Okay, so in initial state, the root is not showing anything, so the branches should also not be created. But then if the vine grows, then those curve points on the curve should start to appear as a branch. Okay, So that's my plan, and let's see. Now, let's start by counting up the number of points, which is, well, maybe I don't need that. First thing I would like to do is to create a project this point to a root, so to calculate the distance. And if the distance is more than 0, then that means the point is not on the curve, which means it should be deleted. It should not appear yet. So I'm going to use XYZ distance with each of the point projected on the curve, and let's also get some additional informations like primitive number and vector UV. Okay. Now, if the distance is a bit far from the curve, you should just delete the point. Okay. Now, the point only appears when the branch is long enough. I mean the vine is right there for the point. Okay. Okay. So next, let's also create some branching line on each of the point. Basically, I'm going to use this rule of golden ratio for each point, meaning the distance, the angle between each of the point, each of the branch will be somehow 137.5 degrees. That's the golden ratio rule in order to create the branches, in order to create a natural looking branches. Let's see if it's gonna work. Okay, so else. So first of all, I need to have, in order to create a branch, I need to have the direction of the branch, right? And currently I only have a tangent vector value, which is Vn. Okay, so somehow I need to create some perpendicular directions to this n in order to create a branch. So let's start calculating a perpendicular branch, perpendicular directions to this n, which is not that hard to create. You just need to use a cross product between n and tangent vector value and some random directions like x direction. Could be z, could be y. It's better, but in this case x or z is better because it's going downward, and there's a chance that the tangent vector will become like exactly equal to y. So in those cases, cross product doesn't really work much. So it's better to avoid any vector value which could be equal to a tangent vector in this case. But in this case, maybe x should be fine, probably. So I'll just choose x and then normalize it so that the length of the vector will be equal to 1. Okay, now let's check this out. I'm going to call this branch direction as an attribute, or just call this and replace n with branch direction just to check. Okay, and let's visualize the normal. Now it looks perpendicular to the curve and it looks fine. So this will be the starting point for the branching. Now what I want to do is to kind of rotate each of those normal directions along the axis, in this case a tangent vector value. And as I said, might want to use a golden ratio angle, which is 137.5 degrees for each point based on its order. So let's try that out. And to do that, I need to create a rotational matrix, and let's create that one. So what I want to do is to just rotate this branch direction, which is currently shown like this. And in order to rotate it, you need to have an axis and also an angle. So the angle in this case, I could try using 137.5 degrees multiplied by the point number, which should go from 0 and increment it by 1 for each point from top to bottom. Then the axis, which is n, which is a tangent vector value. Now the rotational matrix has been created. You can now rotate the branch direction by multiplying the rotational matrix to it. Then update the normal with the branch direction to see if it's being rotated correctly. And looks nice. I mean, looks good. I think it has been rotated nicely. So for each point, if you look at it carefully, starting from the top, at each point you see that it's being rotated 137.5 degrees one by one. Okay. Now if you want to have even distribution for those points, you can always go back to the scatter node and increase like relax iterations like this. So it's up to you for those. Okay. And if you want, maybe you could also apply some randomness to this number to have more natural looking. Probably in nature it's not exactly this value, but there has some noise value on it. But I'll just go with this one for now. Okay, now that I have directions, I can start creating a line in those directions. You might also want to tilt the angle later, but for now let's just try to create some straight line perpendicularly straight from each point. Okay, so in order to do that, you could create a new point from the current point position plus branch direction multiplied by the length of the branch. So for the branch length, I'm just creating one parameter so you can control it by yourself. Okay, and now you might want to connect the original point position and the new point position by creating a line, set it to a polyline. The original point number is pt_num, and the new point will be connected with line. Okay, so let's see the animation. Okay, so far so good, but probably the branch length also needs to start from 0 when it shows up, when it first shows up. Currently it just suddenly appears like this, which isn't really natural. So what I would like to do is that the branch length also gradually grows based on how much the vine has been growth. So in order to do that, you need to know some properties from the frame value, which is being created here, the growth value here. So this frame value, the f value, indicates until which position has been growth as a vine at this point, which could be correspond as a curve u value. Okay. So what I want to do is to get this growth float attribute as a reference and use it to scale the length of the branches. So right now it says 0.18, which means the points until a point which has curve u value until 0.18 is being shown. And if the point curve u attribute is close to this growth value, that means the length of the branch should be close to 0. If it's far from the growth value, then it could be longer. So I think that could be a plan. And let's see if this geometry has a primitive attribute growth, and it has it. It's already been connected to the point wrangle. Let's call this create branch. Okay, so let's refer to this growth value primitive attribute on this create branch and control the length of each of the branch. Okay, so I could get the somewhere around here. I could get the growth attribute from second input, which is a primitive. There's only one vine, so I can just say 0. And now I also would want to check the current u value, which is curve u. So and since I have this condition here, d is more than 0.001, the curve u should be less than growth. I mean, I could also use that as a condition, but now let's just go with this. So the growth length multiplication scale value could be calculated like this. So the growth is bigger than the u, so if I do a subtraction between growth and u, you'll always get a positive value, which goes from 0 to some maximum value. Now I don't want to go till the maximum, so I need to have some kind of a clamping value to this subtraction. So let's say I'll call this scale, and growth minus u, and let's use a minimum function and create some parameter, or let's start with the hard-coded number. Let's say 0.1 as a maximum value for this subtraction. Okay, you might need to have that as a variable, probably max sc. This means that the maximum value of this calculation will be 0.1. Okay, so could be a good idea to normalize it by dividing by max sc, so that the value will be in between 0 to 1 in this case. Now, now that I have this scale value, I could try to multiply it to this branch length, see what happens. Okay, and now let's start showing the animation. So if I play it, now the branch shows up gradually. If it's close to the end, it scales smaller, and at some point it stops growing like these. Now if you increase this threshold value, you could increase the gradational scaling distance or range. So let's call this SG range, scale range. And if I increase this, you can see how it controls the gradational scaling. So let's see, let's say, and I believe 1 is the maximum. So let's say like 0.25 might be a good idea, might be a good number for this. Well, you could always change this, so let's have this as a parameter as well. So going back to the global parameter null node and paste it here. Now the one thing I don't really like is that it just when the root stops growing, the branch is not growing anymore, because it's only relies on the growth value. So it always goes shorter on the end. So that might not be a good idea in this case. So might want to fix that. In this case, growth could go more than 1 probably by using something like efit. Now efit will when you use fit functions, the value will be clumped between 0 to 1 in this case. But if you use efit, it's not gonna, these values not gonna be clumping the value, but if it goes out, it could go out of the target values if the source value goes above this value. So in this case, the growth value could go more than 1, I think. Not really. Nope. The reason is because I guess it's because I have this value, the CH ramp. So as long as I have CH ramp, yeah, without it I could I could go more than 1, but with having a CH ramp it's not possible, seems. So how do I do this? Well, maybe CH ramp only works the volume between 0 to 1, so maybe I could just have another value, probably. Maybe not. Maybe not. It's not a good idea. Oh well. Let's forget about using efit thing. Let's think about other stuff, other value. Now, what will be better? What will be better? Okay, well, let's go back and see this. Okay, so what I'm planning to do is to increase this scale value over time, even if the this value becomes even if the vine growth stops. Okay, so that's a tricky one. It's a tricky one, right? So if the growth goes more than okay. Thing is, we don't really know. If I use efit, I don't really know what will be the maximum for the output in this case. So I cannot really see what's coming after this. So that's kind of a problem. Let's try other stuff, like having some different value to this. So just let's call this time value. And for this time value, okay, well, I'm going to go like this. So ifit, and I'm going to store this f value after just applying ifit to a time. Then right after this, I'm going to use chramp and apply this newly remapped value to f. So the growth value becomes 1, the time value is 1.15. So because the remapping is different, these two values is not the same. But at some point, in this case 130 frame, we're going to have a similar value, and then after this the time still increases linearly. Okay, so maybe I can use that information. Okay, so that's the primitive attribute. Now let's get that information as well somewhere on here. Okay, now for this time value what I could do is by increasing the SC until it becomes 1. So increasing SC by, so if the time goes above 1, which goes above growth value. So what I can do is to subtract 1 by time and make the minimum value 0. Okay, and then try to increase the scale by increase SC and also clamp it so that it will be, the maximum will be 1.0 for the SC. So let's see how it goes. I might need to have an additional scaling value for, speed value for the scaling, but let's see. So it grows. Oop, not the other. Oh, interesting, it just shrinks. So that maybe I'm doing something wrong here. What if I don't have it here? Huh. Well, I was hoping that this increase. Wait a minute. It's the other way around. It's time minus 1.0. Sorry. Okay. So let's see again. So till the end, the branch grows, and after 130 frames. Now, I don't really like how it grows because the speed, it doesn't correspond with the current speed ramp growth. So it's not really good, I guess. It's pretty tricky, isn't it? Well, how do I do this? Let me check the comments. Is using decimals for crafting mathematical functions could be a good use case for that task, or would it be going too low level for Houdini? Decimals. Sorry, I don't know about decimals. Let me know what decimals is. Okay, so I don't really like this scaling. That is because the speed of the time and the growth is a bit different, so that's a problem. It's pretty tricky. I see. Maybe I could what I could do, let's forget about these times. What I could do is make some delay to the growth. So to do that, so this will give you growth subtract by u. So I'm not sure if it's gonna work, but let's see. If I do this, nah, it's not gonna work. Oh, but maybe maybe not, but yeah, doesn't work. An online graph plotter with ability to create your own sliders and didn't know about that. Looks interesting. I might want to check into it. Okay, so how do I keep making these branches keep growing till the end? Well, one idea could be to just avoid having this left and view. Let me see what will be the good idea. Well, as long as I'm using this growth value for scaling, that might not work, so I might need to think about other other stuff. Okay, so what's that? What will be that? What will be the solution? Now this will give you the current 0, right? And okay, so for each point, maybe I can just increment the growth value based on the time-based value, I guess. But well, the growth is still a time-based value, but let's see. What I want to have is the current frame value when at each of the vine points. So, which is good with these value, I think. Or you can just say frame. So for each point, or so these are the frame value, which just shows up the current frame number, so it doesn't really mean anything. It's getting tricky. Maybe I'm thinking too much. Should be simple enough. I just want to just grow the length over time, so what's so hard for that? So after having the scale, I could also increase these value just globally based on the time value maybe. Based on the frame, or yeah, maybe based on the frame, and multiply by, I don't know. Well, no, that doesn't really make sense, I guess. What I need is in which frame each point has been created. I think that's the value that I need. So after I have ramped the value with f, might want to remap it back to a frame by using fit functions again. Fit01 for f goes from f start to the same range. Which should give you the current frame. Although this is just a primitive value, so doesn't really give you information for each point, I guess. Huh. Right. Instead, what I'm gonna do, going back to this geometry, the primitive, okay, which hasn't been trimmed yet by carve node, but going to use a point wrangle and copy this ramp parameter and so what I want to do is to create some similar growth value for each point. I guess which can be used by like kind of a remapping the curve view value, which I don't really have it right now, so it should go like this. So let's try to copy these for code to here, and instead of remapping the frame, I'm going to remap the curve view, which goes from 0 to 1, and then remap this to frame to f star by f end, and copy the frame end value, also copy the ramp parameter to here. Okay, then I should probably use this ch ramp right inside this, or do I need it? Yeah, I kind of need it, but well, this will give you some different results. That's not a good idea. I need to kind of do a reverse. I mean, I need the input in this case will be y-axis, and what I want to have is the x result. So I cannot just use ramp as it is. It's pretty tricky. Okay, well, forget about this. It's getting too complex. What was that I wanted to do? Just wanted to grow the branch over time. That's all I wanted to do. It's not getting there. So what I could do is maybe just stop growing, stop this growth, not till the end, meaning not till point 1.0. Well, let's say 1.7, see what happens. Okay, but originally it still has some curve. Wow. Okay, well, first of all, it should work without the ramp parameter. So let's do without the ramp to see if it's gonna work. Meaning, forget about slowing down for now. Slowing down speed for now. Let's see if it's gonna work. Hello, thanks for the comment. I'm very curious about current progress going on time, but I just have an idea. Remapping initial lengths of branch and growth full lengths can solve the issue. Remapping, adjusting initial lengths of branches. Okay, I see what your point. Yeah, I think that will probably work. Yes. I will try that if my things that I'm trying right now didn't work. Thanks for the advice. So where was I? So yeah, so I was having, so this one seems to work. It's because I'm currently using efit function. So the growth value will be more than 1, which gives you a possibility that this SC becomes more than 1. Yeah. So that's good. Let's see if... Okay. Good. I wonder if it really stops the maximum of 1. It does seem to. Okay, so yeah, shouldn't go more than 1 with this calculation, because u is in between 0 to 1. So okay, so maybe this is a good idea, although initially I was controlling the speed of the growth. Now it's not controlled anymore, so it's not really what I was looking for, but I don't really have an idea how I can fix that. Well, maybe I could implement some time shift violator to control these value using ramp. That's one thing you could do. Maybe I'll do that. For now, I think I'm good with these setup. So I might come back to control the speed by ramp later. Yeah. Let me just think. So after growth, after it's been appeared, which moves as a FU value. From there, from there. Okay, so this one gives you well, I'll come back later. Now, let's go back to where I was. So I have now a branch and a root. Oops, not this one. Let's merge the root and the branch. The next thing I want to have is a seed objects attached on the tip of the branch. Okay. So, and also control the angle of the branch as well, like tilt angle of the branch. So let's start creating some seed object, which I'm just going to use a sphere for that purpose. Okay, so I'll just go with the simple sphere shape for the seed, and try to make it as low res as possible in order to avoid like high calculation cost. So let's say 8 by 8 will be a seed instance. I think it's okay with the polygonal mesh. I'm going to scale these seed shape to make it look a bit more like a seed. Now, next I'm going to use a transform node to reshape this a little bit. Let's scale this 0.6 to x, 0.6 to z to have more like a peanut-like shape, and I don't know, maybe 0.8 to y, 0.5 for x and z. Okay, somewhere around here. Okay, now since I want to attach this seed to a tip of the branch, maybe I might want to attach the seed at this point where the branch touches. So let's raise this up a little bit upward. I could just use match size node. And justify y to minimum. We'll just raise this up, placed on the middle. Looks good. Okay, now let's say this is a seed instance and try to attach this to a branch. Now going back to where I was creating a branch line, so at the tip of each branch I want to create a a seed. So, and I would like to use a copy to point node for that, so I might need to set some group to each of the tip of the point. So I'm going to attach a group. I'm going to set a group for each point, each newly created point. What should I call it? A set point group. Branch tip to each of the new point with 1. Okay, Now I also might need to set the normal directions or up directions to each of the point, but let's see if I could copy the sphere, the seed geometry to each of the point. What's happening? Ah, it's the other way around. So the target points will be branch tip. Okay, so obviously the sphere is a bit too big. I might also need to set some scaling value for each point. So let's apply. Or you could also just control the original geometry as well. Original C geometry for the P-scale. Whichever you like. But I'm gonna try to control the P-scale in here. For the copy to point node. So let's say 0.15. Now obviously the orientation is wrong. It is attaching to branch point, but its orientation is not correct, so let's also update a direction. Should I update the up direction or normal directions? Let's see. I do know the tangent vector at this point, the tangent direction at this point is branch direction. So let's try to set the up for the as a branch direction. See what happens. Nope, nothing happens. So maybe I should set the n. Okay, now it's kind of a perpendicular direction, so I should either update the normal directions perpendicular to a branch directions, or I could just rotate the original geometries 90 degrees to x or z axis. Maybe just rotating it is easier. There you go. So more like cocoon to me. Okay, but it does show you some sorts of results. Okay, so let's merge it and see the animation. So same for these seed, it just appears too suddenly, which isn't really good. So I should do the similar stuff as I did for the branching, gradually scaling based on the current root end. This looks a bit interesting, but that's not really what I want. So I do have this SC value, so maybe I can just reuse this for the P scale. See what happens. That looks a bit more natural, I guess. Now, things that I miss here is the range of these scaling, I guess. So currently the U is curve U, growth is U, so well, I do have SC range, forgot about it. So by changing this, yeah, I could control the range, so okay, forget about what I just said. I am able to control the range of the scaling. Now things that I want to control here as additional stuff is to, currently it's a bit too, looks too artificial how it grows because everything starts at the same timing. So what I want to do next is to apply some randomness, how fast or how slow it starts to grow. That's what I want to apply here. Okay. So maybe some of the seed, some of the branch still isn't growing enough at even at this point. But then after going for a while, it starts growing at some point. So those kind of randomness might be good for nature stuff. So I am thinking where I should apply that randomness. And probably this is the place I should do it. This is where I should apply some randomness to it. Some kind of a offset to the randomness. So I'm thinking I could subtract some random value to this value, maybe. Let's see. So I'm just going to use a random functions for each point. You shouldn't change the seed. I mean, you shouldn't change the seed by frames. It should be applied. You should use some seed based on the point number or point position, maybe, so that you will have a constant random, value based on if you have the same point number, if you always get the same random number. So let's just try with these and multiply what's with some small number like 0.3 and subtract right here. And the thing that's happening is that there's a chance that this value is going to be negative, so that's not good. I should use cramp and cramp it between 0 and max SC. Okay, and maybe 0.3 might be a bit too big. Let's go with 0.1. So now you could see some sorts of randomness. Let's increase this a little bit, 0.2. So you can see that it's no longer linear how it grows. Some branches grow slowly, some branches grows fast, so on. Gives you a bit more natural order, more like a nature order. I'm not sure if it's really accurate. I mean it's not accurate, but I don't really know how nature grows. Not sure even if these randomness makes sense, but to me it looks fine, so I'll go with this. Yeah, I think looks good. Let's also control the branch tilt angle. Currently it's perpendicular to a root, 90 degrees to the root, which is a bit too artificial. If I go back to the images, see how it creates the branches. Not sure if there's any upscaled image. So you have some tilt here, right? It's not really straight as well, but let's not go too detail. I'll just go straight, but I'm going to just change these angles. So it's going a little bit upward toward the starting point. So let's give that angle somewhere in this create branch node. So this is where I was creating branch directions. So I need additional rotation to this using additional axis, and additional axis is perpendicular to a tangent and the current branch direction. So I could have a axis vector value by calculating the cross product between the tangent vector value as well as current branch direction, and let's normalize it. Okay, so this will be the axis for the rotation. Now let's create another rotational matrix. First creating the identity matrix, then rotate that to create a rotational matrix. And the angle, not sure about the angle. Let's start by 30 degrees. And using axis for the rotational axis. Then multiply the branch correction with this new rotational matrix. Okay, so looks good. Just uniformly rotated each branch by 30 degrees. So probably I could parameterize this value. Let's set the range from 0 to 180 degrees or 90 degrees. Okay. Okay, now it might also make sense to make this tilt angle change as an animation. Might be. Let's say the maximum is 50 or 60 degrees, but it starts by 0, so goes from 0, maybe these points start at 0 angle, then slowly tilting like these. I'm not sure if that's the real case, but might be interesting. So let's try if I could do. So in order to do that, I still need to have this growth attributes. So let's bring this part here so that I could refer it for angle. Okay. Now maybe I could still use this SC value for a reference, and I believe the maximum value for this SC is 1, so I could probably remap this SC to control this angle here. So fit 01 SC starting with 0, then in the end gives you tilt angle as a final result. So let's see how it goes. So you can see it tilts over time. Kind of a funny result, but I might want to have a starting angle as one of the parameters as well, so let's copy this here. Tilt start angle and tilt end angle. Okay, then for both of them, let's make from negative 90 degrees to 90 degrees. So let's say the start angle is minus 30, the end angle is 45 degrees. See what happens. Become a bit more dynamic. Now I mean, you could also use different value other than SC for this one. I mean, you might want to have more range for this angle tilting in case of the max SC. So it's up to you. I mean, if you want to do that, you just need to copy all these stuff just for this tilt angle. I'm just gonna go with SC for ease. But to have more control over these gradient changes, you could always do that. I'm just reusing SC for ease. SC, right here. Okay. So overall the branching result looks good to me. It's now time to apply, have some flower part for the jade vine. So for the flower part, what I would like to do is to grow the flower from the seed shape and kind of slowly grows up the flower part coming from inside and grows like this. And if I look at the detail, I do see some like flamingo like shape here, as well as some skin overlaying like that. So it seems like there seems to be some multiple number of layers to these flowers, which is pretty interesting. This is, which one's good? Yeah, this is kind of easy to see the detail. So from what I see here, you have a seed, a purple color seed with 2 layers of flowers, and you having some in middle, like small shape here, or skin like shape here. Well, I'm just gonna skip the middle part, but I'm going to create this skin part and these skin part, so 2 layers. And not gonna go really detail for these shapes. Maybe you can just, in this case, it might be better just using I don't know, Blender or anything, polygonal vertex based modeling shape, in order to create some kind of a custom shape like these. Since I am just using Houdini, I'm just going to do mathematically to create a similar shape, which is not really equal but similar, starting with the seed shape. Okay, so what I'm planning to do is to first of all create some opening or hole onto this seed, so that where the flower comes from. I'm planning to create a hole on top of the seed so that the flower can go out from that hole. Okay, so that's my plan. Let's do that. So in order to open up the hole, the easiest way is using clip and to the Y direction, increase the distance. Okay, other way, -1. Okay, so it's up to you how much of a hole you want. Not sure. Let's say -0.7 around this shape. Maybe it's a bit too big. -7.5 maybe. I don't know. Let's go with 7. Okay, now next thing I would like to do is to, let me check. So what I want to do is to create a flower from this hole. So I'm going to just pick the top part, the top outline, and then start creating some flower-like shape from there. So to do that, in order to retrieve the top outline, I could first of all create a group for the edges. Let's say naked, and enable include by edges and check the unshared edges. Then use convert line to pick that edge to create a outline for those group named naked. Okay, now I don't really need other points, so clean this up. Okay. And let's make sure the point number is equal to 8. Okay. Which is set up right here, rows and columns. Okay. Now, next, what I want to do is to have create some column-like shape. Create a tube-like shape making this extruded on Y direction. So let's create a poly extrude. And let's say I can only choose normal, which is currently I don't have it. So let's create an attribute, create node, set the point normal to make it vector value and to Y direction. And going back to poly extrude, I'm going to use a point normal existing, okay, which will create a extrusions on Y direction. Now I can create some extrusions on Y distance, and this will be the size of the flower, so the height of the flower. So let's check the ratio. What's the size difference? So if the size of the seed is 1, the flower size could be something like 3 to 4, 4 to 5, somewhere around there. So let's say 4. Okay, we can we can always go back to change this scale. Now, and what I want to do is to control this column shape to a flower shape. So in order to do that, I'm going to add some enter points, those divided points, which now I can control these point positions to create some shapes. Okay, gonna create like 10 divisions. Right. Now, let's do some shaping using Vex as always. So, to do the shaping, what I'm going to do is to get the minimum point position on Y direction, maximum point Y coordinate, then use those Y information to get each point's coordinates and normalize it from 0 to 1, then use those values to shape the section using ramp parameter. How's that? Okay, let's try that. So first thing first, let's get the minimum and maximum point position of this geometry by get bbox. Now let's remap this Y value of each point based on the minimum and maximum to 0 and 1. Normalize this. Okay, now that I have a value in between 0 to 1 and normalized value, I could now change this value to a x directional value by using a ramp parameter. Okay, so the x-axis of this ramp corresponds as a y coordinate, meaning the y coordinate of the y value of this ramp parameter will correspond as the x coordinate. It's kind of confusing to say that. I'll just show. I mean, currently it's linear changes, so if you just use this x value as a point x value, you just get these triangle-like shape. But now if you control these shape, you can see you can control the custom sections like these. Currently I'm just applying it to the x, so z is not affecting. So I should also do the same thing for the z, maybe using different ramp parameter. So starting with the x, I shouldn't. First thing first, I need to make the smooth curve for ramp. So making B-spline. Oops. Making it B-spline. B-spline. And making it more like a pointy flower shape. Now currently I don't really have a value for the width or the depth of this flower size. I should also have the parameter in order to control the width of the seed. So let's have that as a additional value here. So let's give the range from 0 to 10. Alright. Now, one thing I was forgetting is that I don't really want to increase this bottom part. Currently, if you look at, so that is because it's coming from the seed geometry, right? So I want the bottom chain to be aligned with the seed hole shape. But if I use a ramp parameter like these, there's a chance that it goes off the shape like this. So in order to prevent having situations like this, what I could do as a technique, I could have additional value using the same CH ramp at 0 point, just at the 0 point, meaning right here where the x value is 0 for the ramp, and you will get this value here, right? Only this value, and this part is correspond at the bottom shape part of this column. And for the bottom shape, you always want the scale to be 1 so that the shape is not going to change because you're multiplying it as a scaling value. So what I want to do is to change this value that I have here at 0 positions to 1. So you can just do that by x divided by x0, which as a result give you the first point value to be 1, and all the other places will correspond deadly scaled based on that calculations. Oop. And like that. And for the width, For the width, I should have, what I should have done for the width is something different, I think. So what did I miss here? So maybe just changing this shape will just give you a more than one scale value, so maybe I don't really need to have this W parameter after all. It's a bit tedious because you have to control the shape just by using these ramp parameter. So for some of you it might not be good enough. You might want to control it by numbers, but in order to make sure that the starting point, the starting scale to be equal to 1, maybe this is the best practice for now. Anyway, that's how I do it, and that's currently this is only for the X directions, so let's also control for the Z direction, just using the same method. I'm going to copy all these, create Z, ramp, the reason why I'm creating a different value for X and Z is because maybe on one side it's more flatter than the other side. That's what I thought. So let's make this B-spline. Like this goes right here, goes right there. Let's check this section, and let's say this is more flatter than the X. How's that? Okay, well, not too bad, I guess. Maybe I could have additional control points, something like that. Maybe. All right. Okay. So next things that I want to do. So let's say this is the first layer, which isn't bended yet. I'm going to bend this layer. I want to also create a second layer, which is this peel skin. Okay, so I just created this first skin. Why the detail in detail wise it's not really similar, but let's just say I kind of deformed it. So let's create this skin part. So in order to create the skin part, I'm just gonna go lazy, just gonna cut this into half and make it as a second layer. That's the laziest solutions that I could think of. Meaning, just gonna use clip. Like that. And let's say this is a second layer. Okay, so now I have a first layer and second layer. What I want to do next is to obviously want to apply some bendings here. Bendings like these. Now, possibly there are two ways to do a bend. One is just using a bend node, which is a bit hard to do procedurally by numbers because you have to do a lot of manual setup for the parameters, but it's the easiest way to do. but I don't really like using bend because it also like changes the length of the whole shape. So in this case, what I would like to do is to use a rig attribute, rig wrangle, to control the angle of the rig and use that rig to bend the shape, just like a character modeling, just like you do in character modeling. And since you have 2 layers, I'm gonna do 1 and 2. I'm gonna create a rig for each of those geometries. So well, this is just one line rig, so it's pretty easy, I think. And you just need to bend it. So it's not really hard to do, I believe. So let's try doing it as a practice. So first thing first, I'm going to create a baseline in order to bend this geometry. So Y direction, and should have enough points for the bending. Like 50 points is enough, I think. And let's also resize this line so that it matches the height with these flower shape. So match size. I'm gonna use match size to control the scaling and position. Okay, so I'm going to scale to fit. That just fit the line inside the flower shape. Now that looks good. Now I think I can reuse this rig line for the layer 2 as well. So let's go with this. Now, in order to use this for rigging or kinefx, I'm going to use a rig doctor to apply some transform attributes by checking initialize transforms, which will create a bunch of attributes to the points, like local transform, which can be used to control using rig attribute, rig wrangle, rig attribute wrangles. Okay. Now let's name this a base rig. Okay, now I also need to use this line to capture the geometry. 2 geometries. One is the flower, one is the second layer cut in half. So let's capture all all these 2 geometries. So in order to capture the geometry by rig line, I think the practice that I always use is first of all using bone capture lines to be connected to the rig, then make sure that the geometry is filled or closed. Currently this is an opened shape, so I'm going to fill the hole by polyfill. Then remesh to have some resolutions on top of the geometry. Then use a tet embed node to actually capture the geometry. Okay. Now after this, I could use a bone capture by harmonic node to actually apply some weight to this original geometry. So connect this flower shape to the first input here, first input of the bone capture by harmonic, then tet embed to the second input. And if it goes alright, you should be able to see some gradient color by enabling this show handle node, show handle icon. Okay, so that looks fine. You just need to do the same thing for this second one. Now you already have the bone capture lines here, so you don't need to do this one second time. What you just need to do is you probably don't need the TET embed as well, so I guess you can just replace the first one, and that should still work. Yeah. So now you have two bone capture by harmonic, and you can use these two to to actually bend the geometry. By actually bending just these lines, you can also bend these captured geometry as well. So let's try that as a sample. What I'm gonna do is connect base rig to the first input of this rig attribute wrangle. Then for the second input, well, I don't need a second input. So let's try rotating or bending this geometry by modifying the local transform, which is pretty easy. You just need to rotate the local transform, which is transform matrix, and let's see. Let's say I would like to rotate each point by 5 degrees using X as a rotational axis. Okay, just like that. Then one thing you need to be careful is that this angle is being applied to each point. So if you have more points, you're going to have more rotations, more bendings. If you have less points, you have less bend. So in order to have a consistent bending amount, even if you have tons of points or less points, you need to think about how you apply the angle here. So one of the idea is to divide it by the number of points, which then you could have some consistent angle even if you change the number of points. So let's say 90 degrees. So it's more of 90 degrees bendings, and even if you change the number of points, which is set it here, you are having pretty much the same result. Okay, I think which is pretty important. If you don't have this endpoints divisions, you'll get totally different result. So if you set 5 and if you change the number of points, you see the change is really drastic. I believe even if you change the number of points, you want to keep the angle the same in this, especially in this case. So I'm going to divide it by endpoints. Okay, which should make sense. Now for the angle value, let's set some parameters as maximum angle. Let's set the range for this angle to 0 to 180 degrees. Alright, now I want to do the same things for the second layer, which I believe the bending angle should be different. Could be a bit more bended like this. So one could be bended 180 degrees, one could be bended a less, like that. So this will be the first layer, and the bottom one will be the second layer bent. And each of the bend I want to apply it individually for each by harmonic captured geometry. So to do that, you could use a node called bone deform. So for the first input, you could connect this bone captured geometry, and for the second input, you should connect the original rig without any transform, and then you should connect the third input to as a deformed rig. So as a result, you will get a deformed original geometry. Okay, so do the same for the second one, and you'll get a shape like this. And now I can see that it's bending in the different direction, so let's fix that. Well, I was using X axis to rotate, but instead let's set Z. Same for this one. Let's set it to Z. And let's going back to the image and see how it looks like. So it looks like the okay, so it should rotate in other direction, and so this should rotate it in the negative direction, right? Like that. And this also to the negative direction, like that. Yeah. So I don't really like using negative, so let's just have negative here, negative there. Now it looks like a cone. Alright. So how's this? So now we have a base shape for the flower. Looks really like a cone. I mean, in order to have more control, you could go in deep into the rig or add wrangle in which point you want to have more bendings in order to get the result like we saw on the website as an image. For example, probably you have more bendings on the tip of these curve. So in order to do that, you could apply some gradient angle based on the positions. And the positions, you could get the positions by I don't have the information right now, so if you want to have a point positions for each point on the curve, just like I did for the root curve, you can use resample and promote curve view attribute and use that. So I believe let's go back to the rig. So the point starts from here, right? Then gives you some value here. So what I could do, just want to control the angle based on the curve view for this one. So let's say multiply by fit 01 f curve view. So starting slowly but bends more strongly on the end. And you can also increase the maximum. So you see some differences. It slowly bends, but in the end you have more drastic bends in the end. You could make it more drastic by making this part smaller and make this maximum angle a little bit bigger, like that, which might be close to what we see on the image on the photo. I don't know, it's up to you how you feel. I'll just go with 0.5 and make this somewhere around here. Probably apply the same rotation to this one and make this angle a little bit bigger, like that. Okay, well, I think it's good for the base. Now let's say this is good, and let's see if I could merge it with the seed and see if it fit nicely together. So where's the seed? The seed is here. So, well, I see one problem here. It's not attaching at the starting point. That is because I'm applying a rotation on the first point as well. So what I could do is to disable the rotation just for the first point. Okay, which is easy. I could just say go in here, and if pt_num is equal to 0, just return, which will skip the later code, and do the same for this code. And that will, it's close. Maybe I need to go until 1. In order to avoid the rotation. Yeah, that might be good. Well, I still see some gap here. Maybe that was not the problem. Maybe something is a bit wrong here. Well, what about the the original geometry right here? Is it correct? Is it really fitting with the seed? I guess it is. Yes, it is. So maybe that was the best effort. It still is trying to touch. Maybe not good enough. Well, it's also based on the weight for the capture geometry, so maybe you just want to make this value bigger until you don't see any deformation on the bottom. Maybe this is good. It also depends on the point resolution, so it's pretty hard to estimate it. Well, let's just go with it for now. Okay, so we have seed and flower, which looks like a cone right now. Then let's replace this here and see how it looks like on top of the branch. Now it looks a bit off. Okay, what's happening here? So obviously the orientation is not correct, not what I was assuming. So it's, what's happening here? So it's kind of rotated 90 degrees to what I wanted to have, or I guess I'm missing a up vector to the branch end point in order to control the orientation of this flower. Previously it was just a sphere, so I wasn't necessary to set the up vector value, but now I do need it in order to control these orientations. So let's do that. Okay, so let me go back to the website where I was checking the shape. Okay, so it goes upward, and currently the line is a bit drastically curved, so in order to be able to see the effect clearly, let's reduce the amount of movement just for seeing it clearly. So okay, so now I see it. Let's go back to the branch creation part and add additional marker here to visualize the up vector value, so that I can see in which direction I'm creating a up vector. Okay, so everything is on perpendicular directions, and I don't really have it on these tip point, which is a problem. So let's update that. Okay, so I do have normal directions, and what do I need as an additional informations? I mean, I could try just setting a tangent vector value to a up vector value, which currently is being overridden here, so I should do this in the last line. Okay, let's see what happens. So I've just updated the up vector, which is supposed to be perpendicular to the normal, but let's see what happens with this result. So now it's 90 degrees rotated for each seed or flower. So what I can just do as a quick fix is to rotate this seed by 90 degrees on the axis. It's the other direction, like that. So that will probably just fix the problem. Alright, now another problem here is that it's just facing a bit. The branch angle is fine, but the angle of this seed itself is not really correct. It's facing orienting upward too much, so maybe I should fix that. Should I change y value here? Okay, so maybe somewhere around here looks more like it, probably, which is, I guess it's close to what I see on the image. Okay, so I'm already having some animation here. Seems to glow a bit too fast, I guess. And too much points. That's too much points. That's a lot. That's a lot, and now I realize that I should have some scale like variations as well. I mean, scale is a bit too similar to each other. So that's one things that I need to change. So reduce the number of points. Alright, looks good. And also maybe I should still make the last part scale a bit smaller than the top part. So I could go back to a create branch, maybe increase the SC range like that, and maybe based on the size of the seed or the flowers, maybe I could make this length a bit longer and then apply the noise movement back. See if it's gonna work. Now probably I need more. Okay, let's see from the start. Let's go back and check. Yeah, looks good. Looks good. Now, one thing, several things that I still want to do. One is to animate each flower's growth. It's just currently it's just scaling, which isn't really looks like a real growth for the plant. I wanna create an animation in which each plant will grows from just a simple sphere to open up these flowers. So let's do that. And currently the line is a bit too polyline-ish. I mean, too small number of points. Oh, let me just increase this to make it a bit smoother. Okay. Alright, so let's create this animation for the flowers. Now how do I do that? Since I'm using a copy to points to place a flower, I mean, you cannot just copy to point the animated flower, because that will just create the same animation for every instance. But if you want to do the animation for each of the flowers after you have done a copy to points, that's also a bit too much of a high calculations, because you have to do like for each loop for each flowers, and that's gonna cost you a lot of calculation processes. So my suggestions for this solution is to create a bunch of frames for the flower animations, like 60 frames or 100 frames in order to start from the sphere to open up the flowers. Then use the piece attribute options for the copy to point to choose the corresponding flower frames to copy, to make it look like it's animating from start to end. So that's, I guess that's the less processing, that's the less computing resource you could use. I mean, that's the that's the least processing I think I could think of in order to create the simple animations like this. So, meaning that I want to create a animation for a single seed, open from the one single seed to open up the flower like this. So the plan is starting, I could control the bending angle as well as the scale of this flower shape in order to create the animation. Okay, and for that purpose I could use for each loop. because it's not contained any frame-based value here. I could just I don't really need to recalculate for every frame for this for each loop, so I think it's good to use for each loop for this purpose. Just need to create a frame, animation frame, animation steps for animated geometry for each frame for this seed as a separate geometry. So to do that, this is where it should be animated. This is where I should change the parameters. So these parts should be inside the for each loop in order to change the values, time related values. So what I would do is to first of all make a group for each of those bone capture geometry. Let's name this layer 1, layer 2, then merge it. Okay. And I think I also want to have a seed merged into this. So connect the group here, name it seed or bean or whatever it is. Now I have 3 types of geometry: layer 1, layer 2, and seed. Then connect it to a for each number loop. Currently I'm creating 10 frames, but could be something like 60 to create the smooth animations, probably. Okay, now inside this loop I want to do the similar things that I did here, changing the values based on the iteration. So first thing first, I'm going to use a split to get layer 1, layer 2, and the seed. Okay, now for the layer 1, I'm replacing this output to here. And then for the output, just connect it here. And maybe I should output this merge node. Now for the layer 2, I should connect it to bone deform, the first input of the bone deform. Okay, now let's move this, organize this a little bit. And now disconnect this here. Okay, and now I am also going to merge the seed to the merge. Now currently I'm just duplicating the same geometry for 60 times, but by changing these angle value based on the loop iterations, I could create a kind of a geometry for each frame. So to do that, I'm going to connect these value here, and probably I'm just going to use the same code for the rig attribute wrangle 1 and rig attribute wrangle 2. So I'm just going to copy the script, just paste it so that I can just reuse it. Okay, now going back to a wrangle 1, what I want to do is to control this max angle value based on the loop iterations. So iterations is a detail attribute coming from second input, right? then maybe you want to normalize it. So let's also get the number of iteration as well. Right. So the normalized value of the iterations is iteration divided by number of iterations minus 1.0. That is because the number of iteration is, if the number of iterations is 10, the iteration starts from 0 to 9. So in order to get a result 1 as a divisions, you need to subtract by 1. Okay, so this will give you a 0 to 1 value as an iteration value. Now I can probably multiply it here to the maxed angle. Oops. I'm missing equal here. And as a result, you're getting some sort of a geometry at each frame. Total 60 frames from straight angle to bended angle. Okay, I'm not sure if it's okay to go by a straight angle. Maybe I should also control the starting angle as well. In those cases, I should change the name of the parameter, I guess. The max angle is okay, but I'm going to fit 0, 1, I, and minus radians CHF start angle. Okay, how's that? Maybe I don't really need my negative here. So if I change this to 45, we're going from the other direction, which might be interesting. Okay, so let's go to the layer 2 value. You need to have a corresponding parameters here. Start angle. Let's also have some angle value here, like 100. I don't know, it should be less than the 1. Okay, now let's go to the for each end and click single pass to see how it's been animated, how it should be animated. So the animation looks like this, starting from this angle and end like this. Looks good. Now I also might want to have some scaling to this animation, right? Starting from a small scale, gradually increase the scale and create a shape like this. So going back to the rig attribute wrangle, you could also apply some scaling to this. So the in order for the for the scaling, I just need to do it for the first point, and that will affect all the rest of the points. So what I could do, I could say if pt_num is equal to 0, then apply a scaling right here. So scale for local transform, and then I need these information, so let's bring this right here. So let's say I'm just gonna linearly scale this up. In order to do that, just would that work? Let's see. So starting 0, So you only have a seed. Gradually it's scaling up. The flower is coming out from the hole and scale up like this. Okay, looks interesting, I guess. I mean, you could also control the speed, how it grows, by applying some ramp attribute or power attributes or something like that, sign like that, but let's go with linear for now. Well, I don't like the intersections right here, so maybe I can fix that later. But now, let's say it's okay. Okay, and the next thing I like to do, just let's also color each of those geometries to see the differences correctly. So I have a jade color flowers, so let's color it in jade color. The jade color is more like a Tiffany color, something around this probably. And then let's also copy this to be used for the second layer. For the seed, I'm going to make it more of a purple like color. Nope, not here. What's happened? What happened? Oops. Just changed all the colors. It's not what I want. I should remove the reference here and change this color to purple. Okay, it's okay for now. Now, in order to be able to use each of the frame as for a copy to points, you need to set this piece attribute for each frame. It says name, but I'm gonna name it as type. I'm gonna name the attribute as type and use integer value for that. So for each primitive, I'm going to apply a type attribute, probably promoted from a loop iterations, which can be retrieved from meta node here for each count node. So I'm just going to, for each primitive, I'm going to apply a type attribute iteration. Right? So as a result, each frame will have its corresponding type value. So type corresponds as the number of frame, in which frame you're in, the geometry is in. Like if it's 31, then the type is 31 and so on. Okay. You probably might want to start somewhere around 10, right? So maybe I could go back to the rig attributes and change the scale mapping. Currently I'm just using I, but probably I should say something like 0.1 to 1. Which, yeah. So this will be the maybe I could increase this a little bit more until I see a bit of a face of the plant. Let's say 0.2. Okay, yeah, maybe this is a bit better. Okay, oh, it's still intersecting. Okay, I see some problem here. I should do a scaling, a rotation using this point as a origin, which I haven't done it. I'm using a 0, 0, 0 as an origin to scale and rotate, so that made it a bit problematic. I mean, rotation is fine, it's because it's just rotating the vectors, but for the scaling I should make sure that this point is the origin of the scaling. Okay, so that's what I was missing. Let's do that. Okay, so in order to do that, probably I also need to do this for rotation, but same for the scale. So in order to do that, for the PT num, I want to make sure that the current starting point transform will be, I just want to move this point to the origin and move this back in the end. Okay, so local transform minus at p. So this will give you this will move the whole curve into the origin. Then after scaling or rotating, you could do a similar process right here, and in this case maybe you shouldn't return after all, but using else instead. Okay, then move this back to the original position when the at p is equal to 0, and there it should be able to have a nicely positioned even if you have a small scale. Okay, now that will give you better result for the scaling. Now you do see some gaps on the whole, but I'll just keep it as it is. Okay, so maybe I can go back to set it to 0.1 at the starting point, or 0 is still fine. And now I have animation like these. Okay, it's good. Okay, so that looks good from, if you look from far away, it's not really, you don't really see the hole that much, so I think that's fine. Alright, so make this back to the whole frame, including everything, which in each part, each geometry you have different types as an attribute. Now it's all I think it's ready. You can now connect this to the transform node, and going back to a for each, copy 2 points. Now since I have a piece attributes, next thing I need to do is to set a type attribute to each of the branch tip point, the corresponding tip point, and this type attribute must be animated from 0 to maximum number of this for each number. In this case, the number of iterations is 60, so you'll be able to use from 0 to 59 for the type. So let's get that information first. I'll just say number of flowers. Okay, and copy these iterations and paste it here. Let's say -1 because that's the number of actual flowers you could use. Okay, now next thing you could do is to, for example, maybe just reusing the SC and remap into number of flowers from 0 to 59 and make it as a flower animation. So shall we try that? So this is where I'm applying all the attributes to blanch tip point. So let's create additional attributes. Flower type by remapping SC to 0 to number of flowers. And this must be integer, so I'm gonna use a rint, round up the number. Okay, now set point attrib to the new point with this flower type value that I've just created, and let's see what will happen. So you can see when it's just started to appear, the growth of the flower is just started. It's small number of frames or small number of types it's being used to show the flower, but in the end you'll see the full shape. And now let's see in the animation. Okay, so you can see that the flower is also growing based on the time. So initially you only have a part of the flowers being shown up, but gradually it's also growing. Right? That's good. Looks good. Okay, so far so good, I guess. Now it's pretty much close to the end. Let's also geometrize or create some thickness to the root geometry, the vine geometry, shall we? Which is not that hard. You just need to create some thickness. Maybe somewhere around here you could apply a poly wire and create some divisions, apply some radiuses, normalize this. Maybe it's a bit too thick. You might also want to control the thickness based on the timeline if you want. In those cases you could apply additional p-scale to each of the point, or maybe copy the curve view to as a p-scale and use it for the polywire. Might be a option. Okay, so maybe thickness wise maybe it's fine. Maybe it's a bit too thick, but I'll say it's okay. I also would like to apply create the thickness to these branches, so let's do that as well. And this branch has some thickness, I mean p-scale, but I'm not using it on the polywire, so it's fine. Let's make it a little bit thinner. Normalize it. Okay. Well, maybe the tip point could be smaller because I don't want to see a section like these. Or I could move the original seed a little bit, going a little bit, moving to a negative y directions to hide those sections. Maybe adjust a little bit like that. That might also be good. Okay, it's not bad. Quick fix. So let's see let's also color these root geometries. I don't know, brownish color. Okay. Now, why am I seeing the whole geometry right now? Maybe okay. Well, I shouldn't have done like this, but I should create the polyline from a carved geometry. That's right. And I guess I also would need to think about the thickness based on the root position, point position. So let's do that by applying a p-scale derived from curve view, I guess, or maybe not. What's the best way? What's the best way? The curve view is not a good idea because it's being carved, so starting point you always have 0 and it's not going to increase over time, so it's not a good idea. So the easiest solution is just recalculate the carve view just for this. Why not? And create a calculation something like this. So the starting point will always be equal to 1, but the end of the curve will always be equal to 0. See what's gonna happen to this. So multiply p-scale to this. So you always have a curve like these. Geometry like these. The tip of the root is always pointy in this case. It's not bad. Now, the reason why I'm seeing these points is because I guess I need to clean this in the end. Or not. What's this? Looks like just a curve. That is because I'm having 0 here, so I should make sure I don't have a 0 value, but maybe minimum is 0.1, maximum is 1. Alright. Okay. Maybe I should do similar stuff for these. Not sure. Maybe this is fine. 0.7. Yeah, I guess that's fine. So, I think I have done pretty much the whole stuff for what I wanted to do for today. you could change those parameters in real time without any kind of hiccups, because everything, the hard stuff is already being calculated right here. You just copy to pointing right here, copying to point right here in almost in real time, instancing it. Okay, so looks overall good. Let me just organize all those parameters that I created in one place right here, so that it's easier to go back to control the shape. Now what do I have as a parameter? So do I have these parameters? No. Let's just promote everything that I could use to control the shape. So first thing, these one. Right here, and let's name this fine noise scale. Which corresponds as the smoothness of the curve. And this is fine noise max movement. Moving distance, what I mean. Okay, resample, I don't really need growth attributes, that's pretty much automatic, but realize I have this ramp parameters, so maybe I can also promote this ramp. This was used, oh, I remembered. One thing I forgot to do is to control the speed of the growth, right? Which I kind of failed last time, so let's see how I can kind of fix it. Okay, I have some ideas. I do have some ideas here. What I could do is let's go to the end and let's see what's the gross value. So it says 1.28692. Okay, well, that depends on how much you set for the f end and how much you have. So you're not really sure what's the end value here, but there is a way to wait a minute. Why am I? Okay, that's interesting. So if I wait till the end, you'll get kind of a scaling with the same value in the end. Now I forgot one thing. Before doing this, I might want to implement some random scaling for each flowers to make it a bit more natural, because currently every single flower is on the same scale, which is not really natural. Looks artificial to me. So let's give some noise or randomness to the final scale, shall we? Which is being controlled as a P scale right here. Okay, so this is why I can add some randomness. So I could just use some random based on the point position maybe, or the PT num, plus some seed and fit01 to give a range between, I don't know, like 0.5 to 1.0. see what will give you as a result. Okay, well, not bad. 7.5. Yeah, not bad. I mean, much better than just using one. You do have some starting to get some variations. Okay, well, maybe a little bit less, like 0.6. Okay. All right. Now I might want to go back to the create branch and probably increase the range a little bit more. The things that I don't really like right now is how it stops growing. You see that each time it stops grows for each flowers, it looks a bit too sudden. So when gradually stops it. So this is not a matter of SC range, but it's the matter of how you control the SC value right here. It seems like this is more of a linear value. That is because the gross value is linear. That's why. Yeah, makes sense. So, in order to make sure this is not a linear value, well, one thing I could think of is I could estimate the end frame value using the same efit right here. Instead of using the frame, I could use fend, which will give you the end frame value. Right, so let's name this growth end. It's a primitive attribute. Let's check. So in the end, you'll have 1.8683 something like that. And and you could check that by moving the frame to the end. Okay, so having this value, I could actually implement the ramp parameters after all. That is to what's the name of the ramp? F ramp. Okay, so F is first of all, I can remap the current F value using fit functions and start from 0 to F end. That's the maximum, and then normalize it at this point, and then ch ramp, using ch ramp to control the speed of the animation from start to the end. Then in the end, you could remap this again to make this back to 0 to the f end, which was the original value that I had as a end, maximum end. Now that should create more gradually stopping animation, I hope. Gradually growing animation. Is it? I'm not really sure. Well, actually, I might, since 130 frames is the end of the animation, and currently the animation has been stopped somewhere around here on the ramp. So in order to have the similar effect, you should make sure you have a ramp like this, I guess. So that, oh, maybe not. Maybe not, that was too fast. Huh. Nope, I was wrong. Sorry. So, well, it still stops at 130, is it? Well, it doesn't look like so. It seems like it stops at 70 frames, which makes sense because that's the half of the frame, right? So what would I do? What would I do? Sorry. I guess I guess if it now this part I might just use this one for the input here. Yeah, that was it. Okay, I think that was it. Now what I'm missing is the the growing after this. Okay, that's it's not good. Well, let me try. Other let's rename this to F mid, and this one to F end. No, it's not really doing anything good. Okay, well, what do I miss? So this one just grows really fast, but it does use F ramp, but it's a bit too fast. That is because, yeah, it does make sense. If you just make this linear, then it stops at the same frame. So I guess you just need to increase this F end out. So instead of using the exact frame number, maybe I should use some float number from 0 to 1 instead for ease, because it's not exact. This could not be an exact value to control. So let's change this to a frame and multiply it with the F end. Okay, now it will be more like it, I think. So if you have a large number of F end, it stops slowly. If you have a smaller number, it just This finishes up quickly. It's too fast. What if I have 0.5? A little bit more to the right. Yeah, looking better. Okay. Yeah, looks better. Now you could always, oh my, now I'm getting some crashes. Oh, I hope I have a backup. Well, that's not new. Eesh. Okay. Let's hope we have some backup to rescue. Let's open up the crash file. Okay, hopefully this is the newest version. Yeah, I think it is. Yeah, I think it is. I remember the shape. Alright, that's good. Now going back to where I was promoting all those parameters. What else? So I have these parameters, right? This is where I was stopping. So the growth. What's the growth stands for? Forgot. What's this? Oh, okay. So this was just a testing parameter, which I don't really use it anymore. So f end is the value when to stop growing. I'll just go vine growth end, vine growth end, and this is vine growth ramp. Alright, so that's the two parameters that I have here. Okay, let's go to the next one. So I have these value. This could be parameterized, but it's not really important, so I'll just... Maybe the radius of the branches could be parameterized, like these. Okay, so... give vine thickness. The range is from 0 to, let's say, 0.1. And copy that value. Let's go to ramp parameters, and I don't really want to show these like parameters, so I'm going to check this off. Show controls by default off, so I'm gonna hide these. Now for the vine thickness, let's say 0.02, copy these parameters and paste it here. Now I could probably use the same value here, just multiply it by, I don't know, like 0.5 or something. Should do fine. Okay, now this one has many parameters. The create branch wrangle. So I have a branch length. Okay, well, this one, I think this one could also be randomized. Now that I realize. Shall we just do that? I mean, this randomness could be related to where I have this random SC. So I can copy this and maybe in order to use this beforehand, should be having the random value right here and multiply it to this one where you're controlling the branch lengths. There you go. Okay, that looks better. Now, where was I? I already have a seed value right here. So I can copy this seed and use it on the create branch node where I was using a random seed. Where is it? I don't see it because I haven't promoted it. Okay. So now I can change the randomness. Do I use any other random here? There you go. Okay. What else? So, the branch lengths. Branch lengths. What was this SC range? SC range is branch growth range. Right, and then P scale. This is a maximum P scale for each flower. So tilt start angle. This is for the branch, right? So branch start angle. And this is the end angle. Branch end angle. Okay, now number of flowers has been automatically defined, so that's fine. Okay, although I could parameterize this one. Number of flower animation frames in the exact. Gonna name this random seed. What else? So for the seed, yeah, I could go to the rig attribute wrangle where I'm controlling the shape of the flowers. So let's have it somewhere around here. The flower end angle. Flower end angle. And flower start angle. Alrighty. Okay, is it? Oh, we have these as well. So we have 2 layers for the flowers, so maybe I should be able to control each one of them. Flower layer 1 max, layer 1 max scale. Wait, this is not related to the layer, but just the angle. Layer 1, flower layer 1. Let's just duplicate these. Name it to layer 2. Oops. Flower layer 2 and angle. Flower layer 2 and angle. Layer 1. Okay, layer 1, layer 1, layer 2, layer 2, okay. And copy this value here to start angle. Let's change this to 70 degrees. Let's go back to layer 2 and angle. Paste it here. Change it to 260 degrees. Okay. So I think I have pretty much promoted all the parameters that I need to control the shape. Think. Let's organize this a little bit in terms of the network. Just gonna use object merge node to bring this base rig. Okay, here. Here, and there. Okay. Let's create a network box and create a box right here. Create a box around here. And the final result comes from here. Okay, I think I have all the parameters that I've set. And what else? One thing I could change is, I think it's these values here. The end frame value, maybe the starting frame value as well. Maybe you don't want to start from nothing, but you might want to start from somewhere around here. So let's give the parameters for the start and the end frame. Start and let's see, what do I get as a difference? So if I make this end value lower. It just makes the simulations slower. It's fine. That's fine. And if I increase the starting point, it will start from somewhere around here and continue growing from that point. Okay, well, so I guess it makes sense to have that kind of parameters. Let's go to the parameter controller, then promote those value. What was that? Right here? Nope. Right here. Okay, so somewhere around there. Fine, grows. Start. I do have some similar parameters already, which was also controlling the end of the growing. Need to kind of think of a name convention. How should I name this? Vine grows. Maybe I should change these names. Frame start. Vine anim. It's hard. How do I name this? I'll just say min. And this one's as a max. It's a bit hard to imagine from the word. And this one as, how do I name this? Fine growth, and well, I'll just go with these. Okay. Okay, now I think everything is set as a parameter. So this is random seed. Well, one thing I forgot is to promote a ramp parameter for the shape of the flower. These one. This could be also parameterized, I think. Okay, so drag and drop the X ramp, Z ramp, name it flower X section. This one has flower Z section. Okay, and make sure you are hiding the controls by default. Alright, now that will give you the whole setup, how to control the vines. Now, starting from the top, you can control the length of the vine, control the length of the vine, the noise scale, and the noise max move, how much it moves based on the noise, divine growth minimum, that's the starting point, that's the end point, and when it's going to stop growing. Yeah. And then you have these vine growth ramp. If it's straight, it's more like a linear growth. If you have this one, it grows fast in the first frames, then it goes slower on the last frames. If it go this one, if it goes slower in the first and going faster on the end. Okay, seems to work. Now, fine thickness, straightforward. Branch lengths also. If it's too long, then it might make sense to make it curvy. Having just straight branch looks really artificial. So, well, I'll leave that up to you. Make it small enough. Okay. What else? Branch growth range. So how much range it grows at one time. Also related to the randomness. Okay. Branch start angle. This is the starting angle of the branch. Okay. The branch end angle and the number of branches. You could go as high as much as you want. This doesn't really look like a jade vine anymore. I need to control the density. And oops. This is the section of the flower. Might change how it looks. Right? It's not. And flower max scale. The scaling max. Depend on how you want to make it look like. Yep. And flower layer 1 stat angle. That was bending angle, was it? Yeah. Is it not doing anything? Let me see. I do have our value linked. Oh yeah, it is working. Although, oh yeah, this is just a starting angle, so that's fine. So that's working. This is also working. Now I might need to change the range. Okay, and the number of flower animations. So currently I have set it to 60 frames, but if you make it lower frames, you will use less computations, but you get more of a glitchy animations, I think, as a result. So it's up to you. I mean, let's say if I have only 14 you see the animation is a bit glitchy, or more of a stop motion animation. You see a bit weird, right? So maybe having a lot of frames makes sense to have smooth animations, smooth growth animations. And then the last you have random seed. I mean, you could implement more randomness to more places, I believe, like the tilt angles, or you could also have, I mean, you could also change the angle in the other direction as well. Currently it's more of close to perpendicular directions, but you could apply some kind of a random orientations to this one. If you go back to where you were controlling the normal, I mean, directions, where you were creating the branch directions somewhere around here, you could add additional like orientation directions to this with some randomness. I mean, this will give you 0 to 1 for each x, y, and z. Make sure to subtract by 0.5 for each value. Now you could add this random directions to this and normalize it, which will kind of drastically change its orientation. The base direction is branch directions, but it's also adding some additional directions, which gives you some kind of a random directional offset. This might be too much. You could multiply like 0.25 or something to have small number of randomness apply to your orientation. Okay, that might do the job. Alright, so far I guess I'm kind of satisfied with the result, and I guess I'm pretty much done with the whole stuff. Let me know if you have any questions or anything, feedback. If not, I think I'll end this live stream and leave this to you to change all those parameters and algorithms that I have implemented. Well, as always, I'm going to upload the files to the GitHub repository as well as on the Patreon page, which you can download for free. So hope you would find it interesting. And I mean, some of the technique shown here could be useful in other projects as well, I think. Alright, so that's it. Thank you very much for being here, watching till the end. I really appreciate it. Well, hopefully I'll be able to do some other lectures on next week around the same time as well. So thank you very much and good night. you can come back to the video description of this YouTube. You should be able to find the link for the download later. I'll do it in 1 hour or so. Okay, good night. Thank you.